Hello and welcome back to Maths with Mitch. Today we're going to be talking about radians. What are radians, how we convert them from degrees, and we're also going to mention why they're going to be useful to you. So let's get into it. So previously when we've talked about angles, we've always talked in degrees. 360 degrees make one full circle. Now this time we're going to talk in a term called radians, which are the SI unit for angle, and we're going to talk about how they differ from degrees. Now firstly we want to talk about what is a radian. So let's think about a circle we have here, and we can draw a line from the center to the outside of the circle, and that is the length. The radius, that's true for all circles, and we've done that in geometry before. Now what I want you to think about is this length, the radius. What if we were to pick that line up and move it onto the edge of the circle, so it's now on the circumference? And I want you to think about how far that will go along this arc length here. It hasn't changed length, so I apologize that freehand, that's not such a smooth line, but that will now be length, the same length as the radius. It's the same line that's been placed there. Think of it as a piece of string. If you were to, rather than have it straight from the center to the outside, that piece of string, if you moved it to be along the circumference, it would still be the same length. It's now just laid in a different position. So that arc length here is the radius in terms of the length. They have the same length. The arc length is the same as the radius. Now if we were to then join that up from the center at the edge of this arc length, so we were to make a full arc with it, the angle inside this arc is now 1 radian. You might see this written as 1 rad, and that is the definition of a radian. It is the angle made up in an arc where the arc length is the same as the radius. Using that now, we can think about a couple of things. So the first is, we said the angle. We're going to call this, if we say that's theta, we can say that theta is going to be the arc length, which we know is the radius, over the radius. Now for the arc we've just drawn and defined 1 radian, then obviously we can say that the arc length is the radius. They're both the same. If this was a unit circle, we could say these are all 1. So here we would put in 1, here we could say 1, and therefore the angle is 1 rad. So that stands up in terms of what we've just defined as a radian, and then with this equation. However, what that means is if you were to do a much bigger angle, so let's say we're now over here and we were looking at this angle, the arc length would be much longer, because you're talking right round to this point, but the radius would still be the same. So you would then use the equation with the arc length of whatever it is. You could measure that in some way, divide it by the radius, which again you could measure, or you may know, and then that'll give you a value for the angle in radians. So that's one way you can look at how many radians you're looking at and what the angle is. Another thing we can also consider is that the circumference of a circle is 2 pi r. And we know that, we've proved that before. But as a result of that, what we can say is that knowing that 1 radian in terms of its arc length here is r, the radius, we can say how many times does that go into a full circle? So we can divide this circumference by r, remembering that the circumference represents the total distance around the outside of the circle. So we can then therefore say, if we divide it through by r, there are 2 pi radians in a full circle. Now of course, a full circle, another way of saying that is 360 degrees. So 2 pi rad equals 360 degrees. So then if we want to compare or convert some degrees to radians, we can do that, knowing that 2 pi rad make up 360 degrees. So if we just do a little table here, say 0, 90, 180, 270, 360, and so 0 degrees is going to be 0 radians. There's no angle there. We've just said 360 is 2 pi, and then we can fill in the others. So 180 would be half of that. So we can say that's pi. 90 is half of 180, so it'll be pi over 2. And 270, that's half again in between 180 and 360. So that is 3 pi over 2. And you can use that to convert any degree into radians. So you can consider it in terms of your angle over 360 is going to be the same ratio as your angle in radians. So that's going to be degrees, and that's radians. So you can always find what it would be in radians. So as an example, we'll just use one of these numbers and that should work it out. So if we had the input and we knew it was 90 degrees, we could say 90 over 360 equals the angle in radians over 2 pi. Let's bring this over here. So 90 divided by 360 is quarter, equals the angle over 2 pi. Now let's get the 2 pi over onto this side, so we can times by 2 pi on each side. So that gives 1/4 times 2 pi, which is the same as 2 times a quarter is a half. So that'll equal pi over 2. And that's what we said there. So you can use this to convert either way between degrees and radians. So that's covered what a radian is, the derivation of how we defined it, and you can now move between degrees and radians and use them to your heart's content. But why are they useful? How are they going to be used by you as you progress through your mathematical career? Well, when you get into calculus, when you start looking at the analysis, expansion of trig functions, then they're going to be a godsend to you. It's going to be a lot easier to manage some of that mathematics with radians rather than degrees, and hopefully it'll all become very obvious to you. If you've liked today's video, please subscribe, please press the bell icon, never miss a video again, and perhaps join me next time for drawing trig functions on graphs in radians. Thank you for watching.